Geometry, equation of a circle. Okay guys, as the name suggests, we'll be learning a little bit about equation of a circle. Okay, so here's the definition. We can define a circle as a set of all points in a coordinate plane that are fixed distance r from the center hk. All that means is that we got a point over here that's distance r away from the center, and all the points that do that, every single point, form a circle. Okay. All right. But if you look at this picture kind of carefully, what do you notice, guys? Between, let's say, the center and the point, its radius r. But what you can do is you could drop a height over here, and you could draw a line across, form a right triangle, right? So what we end up with is change in x and change in y. And if you have a right triangle, what comes to your mind? And if you were thinking Pythagorean theorem, you are 100% correct. Pythagorean theorem. So we know that the change of x squared plus change in y squared. So it's basically like length in the x direction and the length in the y direction. When you square each one of them, adds up to the r squared. Sums of the squares of the legs equal to square of the hypotenuse, right? But if you look at this, how is the change of x defined, right? If you bring it down here, that's x. And if you bring that down here, that is h. And to find the value, change of x is x minus h. So I substitute the value over here, guys. All right. Same thing happens all the way across. That is h. If you go all the way across here, that is a y value. And that length is y minus h, isn't it? So that is the equation, guys. From here, we're given information, the radius r, and the center coordinate hk. What I find kind of interesting when I first learned this as a student, right, is that we're defining the most perfectly symmetric shape in 2 dimensions, which is a circle right here, right? Very round. There are no edges, there are no sharp points through, right? So that is an infinite n-gon. There are no sides. By the smallest number of sides possible for any shape, any polygon, that's triangle. Isn't that interesting? Right? We got 3 sharp corners right here, guys, right? Defining something that is circular and so perfect. Yeah. Anyways, Pythagorean theorem for you there. So, as you could see, so my equation is over here. My center hk and radius r. Okay, let's do some examples, shall we? And here will be very straightforward. We will be plugging the values in there. And let me zoom that in a little bit. And we're given the center and the radius, right? So that is h, that is k. And the equation that we're supposed to know is x minus h squared plus y minus k squared equal to r squared. We're literally going to plug in the values. That's all we're going to do. Okay. So we go, that's x minus the minus 1 squared plus y minus 2 squared, 3 squared. We need to simplify that, right? So we have x plus 1 squared plus y minus 2 squared is equal to 9, therefore. And we're done. And I want you to observe something really interesting. Because we're subtracting over here, guys, right? When you have negative 1 and positive 2, we end up with the opposite, positive 1 and negative 2. Yeah, just keep that in mind, okay? And now the example B that we see over here, once again, that is h, that is k. And what I'm going to do is to drive the point home, I'm just going to copy that over here. Boom, right there. And I'm just going to plug it in. And that's going to give me x minus 3 squared plus y minus 2 gives you positive 2. Now, in this second one, I quote-unquote didn't show that little step, but I'm going to trust that you're capable of doing that, guys. And then, what is a root 7 squared? Which is 7. Okay? So, I'll be perfectly okay with you either showing me the intermediate step or just plugging in directly. As long as you give me some indication of what went on, I'm all good. Okay? So this kind of begs the question. We have squares. When was the last time we saw squares, guys? Right? Exactly. So let's look at that for a second, shall we? Do you remember expanding out the polynomials? Do you remember this? If you have x plus a squared, we would end up with, that's right, x squared plus 2ax plus a squared. Yeah. So when we have x plus a squared like this, that's half the amount. When you square that amount, you get a squared. Now, let's examine that a little bit further, shall we? Let's choose different color here. Now, traditional way that we show this is, let's say, if we have x plus a squared is x plus a times x plus a. And we would use what? Exactly. We would multiply this to the first term and the second term, and that'll give you x plus a times x plus a times a. When you expand that out, we end up with x squared plus ax plus a squared, right? Right, and that added up to x squared plus 2ax plus a squared. So this is the f, that's the oi, outside, inside, last, meaning f stands for multiplying the first terms of the binomial. And the L stands for, right here, stands for the multiply the two last term of the respective binomial. And the oi, that's the smile that you create, right? Outside terms, inside terms that you multiply and then you add. Hence the term FOIL. Okay? So we've seen this before, right? I'm going to shrink this just a tiny bit so that it will create space for me. In other countries, they may show you how to do this slightly differently. Okay? How about this? 13 times 25. How do they do that? You might have seen this actually, right? Depending on the program that you went through. Well, 13 is 10 plus 3. 25 is 20 plus 5. That's like a plus, right? And then if you multiply the grids, that's 200. That's a 60. And that is a 50. And that is a 15. Boom, right there. You just add the tens. That'll give you 110 plus 200 plus 15. This works exactly the same way. So x plus a could be written as x plus a, and x and x is x squared, xa is ax is ax, a times a is a squared, and when you add these two, that's the part that I have here, 2ax. Okay? Whatever works for you, but I'm trying to remind you that's where it came from. But what I want you to do is you have to know this code. When you have x plus a squared, that's the same thing as x squared plus 2ax plus a squared. You have to go in either direction. Okay, guys? All right. See, that was important because for the next example, yeah, we're going to have this like strange looking equation and we're supposed to figure it out. Right. This is called completing the square. CTS, completing the square. Why? Right here, guys. We want to make it look like that. We want to make something like this look like this. Right? Hence all that, remember this segment. So the way we do this, let's take the first one very slow. Okay, let's zoom that in a little bit. We're going to have x squared plus 4x plus something is going to look like what? X. What goes in here? Well, I said it kind of quickly over here, but you see this part, you guys? You got x squared, you got 2ax, but the expanded portion of this square value, if that's 2a, that has to be the a. This term over here is the square of this. Half of that, then let's square that. Remember that, guys. Half of that, half of 2a is a, square the a, you get a squared, right? All right. So, sorry, coming back to this over here. Let's move that a little bit to the left. There you go. And then we have y squared plus 2y is equal to 20. I'm creating a little space here, guys. I don't know if you noticed that right there. Right? Right. Well, what do I need? Half of that is what? Negative 2. When I square that, I get 4, positive 4. So I just added 4 to the left-hand side of the equation. You can't just add on the one side, so I'm going to add on the right-hand side. I tend to draw underline to indicate that I added that equation after the fact. Okay. For this one over here, what is the half of that amount? That's plus 1, isn't it? When you square that, you get 1. So if I also added 1 over here. So on the right-hand side is 25. Look, we have an equation of the circle, don't I? This portion is the h, that is the k, that is the r squared. It's supposed to be minus h minus k, right? So therefore, my center, h, k, then has to be 2, negative 1, and my radius, r, is equal to 5. Please don't put plus or minus 5, guys. Radius is a distance, and the distance have been written as a positive value. Okay. If you feel brave, why don't you go ahead and try this problem on your own. Pause the video. Okay, good. I'm going to go a little bit faster this time. To mimic what we did earlier, we essentially want, we know that it has to be followed by a number, right? Plus y squared minus 4y, followed by a number. And I'm just going to move that to the other side, right? Well, I really didn't need to, but as a general practice, you should do that. It's a much more robust way of doing it. And then let me just use different color. Oops, no, let's get back to this. So we know that half of that is what? X plus 3 squared. When you square that, I get 9. I'm going to add 9 to both sides. Sometimes I put it, slightly under the other one. And then here is, I take half of that amount, which is negative 2 squared. When you square that, you get positive 4. So on the right-hand side, I get 9. Once again, that's h, that is a k, that is a r squared, isn't it? So that right there is the equation of the line, right? All right. So when you do that, hk is negative 3 and 2, and the radius is equal to 3. Now, they asked us to graph the picture, right? Yeah, the one thing you could do here is just go 1, 2, negative 1, points over here. My radius is 5, so I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 here. I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and these are the main points I need to consider. And I do my best to connect these points, and that, to me, should be sufficient, and all you gotta do is indicate that that is HK. Because I already wrote the value here, we're good. Okay, and when we do the same thing for this one, we could just go, that's -3, 1, 2, 3, 1, 2, right there. Let me bring that down a little bit. Okay, now that's the center right here, right? So my radius is 3. You go 1, 2, 3, 1, 2, 3 right here, 1, 2, 3 bottom to the top, and we do our best to make it look circular, and that to me should be good enough. Y and is equal to X, and instead I could put 2 over here, and I could put -3 right there, and that should be sufficient for me. Okie dokie. All right. So now comes the last kind of question for this one. So prove or disapprove the given point lies on a circle. Okay. So the point 3√7 circle centered at the origin contains the point -4, 0. Okay, there was clearly a typo. Okay, this is trying to say that the radius, hold on. That should be with radius 4, and that should be with radius 3. Otherwise, this makes no sense, right? Okay, guys. So if the center is the origin, right, we have a circle here, here. That's the radius right there, right? So I'm just going to do this. It should look something like that. All right. There you go. The question is that point on the circle? That is 1, 2, 3. If it's a 3, it should touch this point. But unfortunately, I don't know what √3 is, right? Question mark, is that 3√7, right? That's the question, isn't it? Okay. All right. So this, if that's the origin, HK is equal to 0, 0. Radius, that's R equal to 4. We put that into the equation, which is x minus h squared plus y minus k squared equal to r squared. When you plug in the value, because hk is 0, 0, it would be x squared plus y squared is equal to 4 squared. The question is, does that contain 3√7 question mark? Well, here's the thing, guys. If 3 and √7 is contained on the circle, it should satisfy the equation. So if I plug it in, it really should work, right? Question mark, does it satisfy? That's 7. 9 plus 7 is equal to 16. Yes, it does. We say therefore 3√7 is contained in the circle x squared plus y squared equal to 16, or you could have said 4 squared. Either one is okay with me. Okay. Now, for the second question, let me bring that down to the other side over here and change the color a bit so that's less confusing from the previous question. Here we go. Let's do this. All right, it has a circle -1, 0, which is center, which is here. The radius is 3, which means it goes 1, 2, 3 here. 1, 2, 3, contain 1, 2, 3, 1, 2, 3. Okay, so it should look like this. Uh-oh. That was pretty bad. There you go. And let me move that just a little bit so that it matches. All right, that's the best I could do right now. All right, and the question is that right here on the circle, right there. Is that point 1 root 6? Because that's 1 right here, isn't it? Root 6. Okay, we should approximate that, should we? I mean, we could have approximated 7, and the way you would do that, 6 is between two perfect numbers 4 and 9. If I square root both sides, all of them actually, so root 6 is between 2 and a 3. Because it's a lot closer to 4, the gap is 2 versus 3, root 6 should be about 2.3, 2.4, something like that. It should be less than 2.5, right? And yeah, I mean, it could, but 2.34 is a little bit higher up here, right? It doesn't look like it, but you shouldn't always trust your eyes. You should let it guide you. Okay. Well, anyways, let's plug this into the equation, guys. So the equation is x minus h squared plus y minus k squared equal to r squared. That is h and a k. When I plug it in, that's x plus 1 squared plus k0 equal to 3 squared is 9. Okay. The question is, does that contain 1 root 6 question mark, right? If it does, if I plug in for the values of x and y, the equation should be satisfied. Let's do that, shall we? 1 plus 1 squared plus root 6 squared is equal to question mark. Is that equal to 9? So that's a 2 plus 6. No, 8 is not equal to 9. Therefore, we could confidently proclaim that 1 root 6 is not contained in circle x plus 1 squared plus y squared equal to 9. Alright, guys? Yeah, that is it. Okay? Alright. So for your own practice, here it is. It's your turn. Why don't you take a few minutes to work on this thing, right? There you go. It doesn't fit. There you go. Okay. Pause the video. Give it a shot. Okay. Here are the answers. For the first 4 questions, I should underline this thing. Here we go. Yeah. If you got this right, no problem, without too much work, then you are in a very, very good shape. But if you have to work through it, it's kind of hard for you, then we should talk about it in class tomorrow. Okay? All right, guys. Have a good night.